Hi guys, so welcome to second class of the month-long embedded systems workshop. This is like the sixth time that I am trying to record because I kept running into issues with recording and I had to do it over and over and over again. But it's fine. It's fine. I mean, you live, you learn something new every day. So yeah. Okay. So this is the second class. Originally, we had this class on the 11th of January. That was Sunday. But then, unfortunately, the file for the recording got corrupt because of a silly mistake that I made. And now I have to record everything by myself because I didn't want us to be counterproductive because we still have a lot to cover. So I had to record everything by myself. And then um I had to record everything by myself and then I decided to record everything on my own and then just upload the recording to our YouTube, send it to you guys, send link to you guys and send the link to you, sorry, and then now make sure that one way or the other you get access to the recording. Yeah, so that before our next class on Saturday, you guys would have been caught up to speed and we would have at least covered ground to a good extent because we have just 5 more classes till we now move to computer aided design next month. It will start on the 7th of February. And after February, we now move on. Then after February is March. March, we move on to industrial automation. Then we come back to embedded systems again in April. But in April, we are going to our plan is for us to deal with Internet of Things, so IoT. So working with Arduino Cloud and the likes and all of that. So yeah, that's a simple explanation as to why I am doing this recording by myself. Yeah, or two of me anyway, but we shall get the gist. Okay, so let me share my screen now. Because I have a lot to cover, more or less, and have a lot to cover. I feel like I've said that a lot. Well, I just want it to be that we cover as much as possible, as fast as we can. Okay. So this is the curriculum I'm working with. We have covered in class 1 introduction to electronics, spoke about resistance, we spoke about voltage, we spoke about current. I think at some points also we covered a bit of interpreting circuit diagrams, all of that. So yeah, I was also considering adding some more things like inductive reactance, capacitive reactance, and impedance. But I think I'll just do that in our third class so that when I'm explaining, people have time to ask questions and I also have time to prepare. So we have a bunch of videos to look at and then have introduction to Arduino. We have understand and working with basic electronic components, working with sensors, working with the servo, working with the ultrasonic sensor, working with the liquid crystal display, that's LCD screen, working with motors. And then I want us to work on a project at least, even if it's a mini project, so that we will sharpen our understanding of embedded systems. So our understanding of Arduino, whatever it is we cover in this curriculum, yeah, embedded systems, the Arduino curriculum, so that when we go deep into embedded systems, we have a good understanding. So I was saying that resistance, in our first class, we spoke about resistance, voltage, and current. I was saying resistance is the obstruction or the restriction of formation of friction that restricts or slows down the flow of electricity in a circuit. Then voltage is now the force applied to push the circuit, or the force applied on the current to flow through the circuit, or basically the measure of force that is used to push electricity through a circuit. That is what voltage is. Then current is essentially the flow of electricity in a circuit. That's what current is. A simple illustration is this. This is a simple illustration. So as you can see from this image, we have resistance measured in ohms, we have voltage measured in volts, and we have current measured in amps. And this is the circuit that this electricity is trying to flow through. So as you can see, resistance is trying to obstruct the flow of electricity or current in this circuit, and then voltage is trying to push the electricity, push current through this circuit so that it can make headway, but resistance is obstructing it. But either way, voltage is going to keep pushing and will eventually lead to the flow of electricity, flow of current in this circuit. So yeah, that's one illustration. Another illustration is the father-son illustration that I used in our last class. I think I mentioned you being electricity. I don't think I need to draw this again, but yeah, you being electricity, and then I have no idea why this is so light. Okay, you being electricity, then this is the room, and then your dad is at the door, and then your dad is trying to obstruct you from entering into the door, from entering into the room. Sorry, your dad is trying to restrict you from entering into the room, and you are electricity. The room is circuit. This is the door. Blah 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 blah. We all remember this is the room. Sorry for such a mess. The room is the circuit. I don't think I need to write this again. This is the room. This is your dad. This is the door. This is you. You are electricity. You are trying to force your way into the room, but then your father, who acts as the resistor, is trying to restrict you from entering into the room. But then you apply force by you pushing the door with your hands, or using the entire weight of your body to push yourself into the room, and then however it is you move in the room, whether forward, back, clockwise or clockwise, you as the current, that's how you move. That's a simple illustration as to what voltage, current, and resistance is essentially. So now the next thing on our agenda is now introduction to Arduino. And since this is basically me repeating what I taught in the second class, we will cover the Arduino board and stop at the Arduino IDE, because that's where we stopped in the last class. So yeah, let's move. Okay. Well, okay. So in the last class, I was actually speaking to Daniel. That was one of our members. One of our members, speaking to Daniel, and I was telling him about I won't say a concern that I have, but basically I was sharing my own point of view, that a lot of people tend to think that Arduino is not necessarily embedded systems, and the reason why they say that is because they feel like it is so basic or so simple or beginner friendly that it doesn't challenge people enough to be able to say that, oh, okay, I want to Now I am a probable embedded systems, but I don't agree with that motion. I actually beg to differ because I feel like if someone, depending on whoever the person is, were to um see how much of work, I'm not saying this is an excuse for you to be lazy, but some people would see how much effort it requires to actually be a proper embedded systems engineer, and they would give up, right? Because maybe they're overwhelmed by the workload, or they're overwhelmed by the requirements, or whatever it is they have to sacrifice because of it. Um, and I personally, I believe that the Arduino gives people the chance to um the Arduino gives people the chance to at least like break into the embedded systems world, and then when they eventually have their footing, like they will thrive and they will learn more. So is Arduino embedded systems? I believe so. But is it the deep things that, oh, it covers a good majority, not a good major, like it covers a good number, yes, in terms of like basics and fundamentals. So anybody saying that, oh, they want to um saying that, oh, they want to degrade or downgrade or overlook or underestimate someone who knows Arduino, or underestimate Arduino users, I don't think that's fair, because Arduino has given a lot of people the privilege and the leverage that they actually need to break into embedded systems, whether we want to realize it or not. It's how I started. So even if anybody now should come and tell me that, okay, Princess, teach me embedded systems, I'm going to start from Arduino first and foremost, because um because it's what I know and I know it well. There are other aspects, but because this is how I started, eventually you will learn about the ESP32, you learn about the STM32, you will learn about the Raspberry Pi and all of that, even though Raspberry Pi is a microcomputer, no microcontroller, but like you will learn more about that, and then you can eventually branch out and now say that, okay, now I know, I've gotten my footing, I know what I want to do, and I can grasp more, like I can grasp more of what I want to do, you get. So a lot of people tend to overlook it or underestimate it, but I don't think that's fair. So anyway, that's all for my rants. So this is tinkercad.com, and this is the dashboard after I logged in. We did that in the last class. Then I create circuits. Yeah, because we're going to design a circuit now. So I create a circuit. So this is an Arduino, right? This is an Arduino. And an Arduino is a microcontroller that is basically a printed circuit board. I'll explain what a printed circuit board is in soon. But it's a printed circuit board that has other active and passive electronic parts mounted on it. Like we have the oscilloscope here, we have capacitors, we have small little ICs, we have the reset button, we have female headers, we have LEDs, we have the micro processor, the jack, USB, sorry, the power jack, we have the USB ports, and yeah, essentially we have all of that. And the reason why yeah, so all this make up the Arduino, and I'm going to explain all the parts one by one. So what do I mean by printed circuit board? You know how when you are carrying out projects, right, and you have to use jumper wires to connect like the different components or the different parts to each other, right? So let me cite an example. Now, like the example that we used in our first class. I have to repeat this again. Like the example we used in our first class, this is an LED, this is a resistor. So I think I've mentioned this before, that I like to use color code a lot. So So yeah, let me zoom in here. Yeah, okay, yeah. Then bring this one here. And of course, I'm going to make it black. Let me zoom out a bit. Yeah. So essentially, I feel like I say essentially a lot. Um, this circuit now, we connected the positive part of the LED to the resistor, to the positive part of the battery, the negative part is ground to ground, negative part of the battery. So what a PCB does is that instead of you, like imagine we had more components than this. Instead of you having to go through the stress of using jumper wires to connect all of this, right? A printed circuit board will allow you to will have tracks instead of jumper wires, which are basically like traces traces that show like the path that the like the signals or the electricity will travel, the signals will travel. So instead of you having to go through the stress of using jumper wires, these printed circuit boards have tracks. And then all you have to do after designing them, of course, is just mount and solder the components that you want to use on top of them. And that's the reason why we can have this something like this, and then like all these different parts are on top of it because it's a printed circuit board, and instead of using your powers, I could use all of this. So let me show you a quick example. Let me show you a quick example. Hmm. Okay, I feel like this is the image that I'm going to find out. Process what I'm looking for. So let me I keep looking. Okay, so let me try to zoom in. Okay. Oh, this does not give the best quality. I there was a picture, there was a photo that there was a picture that had this, but oh well. Okay, let's look at this. Let's look at this. Okay, so we can see this, like we can see these lines that are connecting to like different parts. You can see some of them that are here connected to the resistors, some of them here connected to the LEDs. Can see some of them connected to this microprocessor here. Can see some coming out of this part. Like all this, like they are connected. So yeah, these are the tracks that I was referring to. Now instead of you using a jumper wire, instead of you using a jumper using jumper wires, you can just design a PCB and then use tracks to connect all the different parts that you want to be connected. That's what I meant. So if we had if this thinker card wasn't like just for beginners now, we would have seen it. But I'm glad that at least I'm showing you guys here. Sorry. Sorry. So I was saying that if Tinkercad now had like a more detailed um display and everything, we would have actually seen them on the board. But oh well. At least I've shown you now, so we're good. So let's discuss different parts of the Arduino Uno or the Arduino board, because most of them have like the same components on them, more or less. Just maybe the sizes, the essentially the architecture is the same, just the sizes and the designs that are different. So yeah, this is oscillator most likely for smoothing out signals. Yeah. So this, let me mention some of the passive components that are on this Arduino board. We have the oscillators, capacitors, we'll discuss capacitors on Saturday. Capacitors, some of the ICs on them and chips also. Yeah. Then we have the inbuilt LEDs. Sorry, we have the LEDs. We have this LED for showing that signal or data is being transmitted. Then this one indicates that data is being received by the Arduino. So transmitted from the Arduino being received by the Arduino. This just shows that the Arduino is on. So as you can see, on. Yeah, on. Then this shows that it is working. So this inbuilt LED shows that the Arduino Uno is working and it is connected to the pin number 13, digital pin 13. Yeah. Then after all these passive components, we now have the microprocessor. So in embedded systems project or any hardware project that you see, there's always something that's going to serve as the brain. Like the way we human beings have our own brains, right? We have our brains, and this brain, our brain is what controls like all different parts of the body. Tells the heart to beat, tells the lungs that, oh, if I run out of breath, taking and breathe in, breathe out, taking oxygen, exhale carbon dioxide, all of that. Oh, I want to stand up and pick up something. Raise your hand, pick it up, that kind of thing, your brain. So for every embedded systems or hardware project, there will always be, okay, for every embedded systems, robotic, any smart device or smart project or whatever, like electrical or smart projects or device, there will always be something that serves as the brain. In this case, the brain is the microcontroller, which is in this case is the Arduino. But this microcontroller, think about this microcontroller or this brain now. This microcontroller, a microcontroller has a microprocessor, which serves essentially as the brain of the brain, the brain of the brain, the brain of the brain. So this microprocessor serves as the brain of the brain. So it is what receives the data, receives code that you send to it, breaks it down into computer code, then sends it to the Arduino, which now sends it to different parts or different electronic components that are connected to them. And then you are allowed to carry out different tasks or projects or whatever it is that you want to carry out. So let me cite an example. Like how we have like our motherboards now in our laptops, and yeah, we have motherboard in laptops. Yeah. So if you open your laptop now, you see some things like this. Depending on the laptop you have, sure, you would see some things like this. So now let's say I open my own system. I would see something that serves as like the center of everything. You may not, it may not even be, I don't know, but like it will not be hard for you to differentiate it out of the others, because you can see one way or the other, whether through the tracks that are coming from it or are being connected to it. It may not even be at the center like this one here, but you will just know that, oh, this is the probably the most important part of this board, and in that in this and in that that is the microprocessor. Like now, for example, you can see this small black square thing here. You can see this small gray thing in this place. You can see uh here also, and you can see here, um here too, here. Like you can see a bunch of them, you can see a lot of them, right? And you can see that at the center of it all, even if it's not like center of everything, like at the center of you will just see something that looks like the most important thing there. And that, my friend, is the microprocessor. That's the microprocessor that serves as the brain and tells the computer what to do, how to do it, receive signals, and all of that. That is the microprocessor. Hmm? That is the microprocessor. But I remember that there was a part that I did not show you guys when I was talking about the PCBs, right? PCBs stands for printed circuit board, and I was mentioning jumper wires, right? So I used an example. I forgot I used an example, so I just want to use it again. So imagine you have something like this, right? I'm going to use color code again. We all know that I'm very big on color coding. This is going to be red, stops here, moves here, stops here. So yeah, this is going to be red. And then this is black. Move this here. Yeah, this is supposed to be red also. So you know how this is, right? The way this is, the way I was able to connect these jumper wires to connect the positive part of this LED to the resistor, from the resistor to the positive part of the battery, then the ground, the negative part connects to the ground of, or the negative part of the battery, right? So PCBs give the advantage that instead of me having to use jumper wires to do this, all I have to do is just design it. Let me see if I have a distance of, I think I have a PCB design somewhere. I think I have a PCB design somewhere. I was working on it. It was a friend that helped me with it, and I was working on it at some point. So let me see if I can show you guys. So rather than you having to go through the stress of using jumper wires to connect all of this, right? All you have to do is all you have to do is I'm coming. It's opening. Okay, let me show you. All you have to do is I'm not saying I'm saying it like designing it is an easy task, but all you have to do is design something like this. All you have to do is design something like this, right? Design something like this. And then with all the holes and everything, let me show you what will now be the outcome after everything. Okay, I can't, okay, yeah. This is what will now be the outcome after everything. So you design something like this, uh, then this will now be the outcome. This will now be the outcome. Something like this. but the headers won't be there, of course, because you haven't soldered it yet. But when you eventually add on, you get something like this. You will get something like this. You will get something like this. So yeah, this is a project that my boss wants me to work on. I've been working on with my boss. I don't know if I should be showing you guys, but I'll just show you because eventually, like, he wanted me to post about it. So I mean, yeah. So when you eventually print it, right, you won't have these headers, of course. Like, you have to be the one to solder the headers on top of on the this thing with on the holes that are here. You have to be the one to do that. But you shall get the gist. Like, instead of you having to use jumper wires, all you have to do is design this. It's not easy. I won't lie to you. Like, it's not easy designing a PCB. It's easy, but it's not easy at the same time. So all you have to do is design one of these, do this, blah 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 blah, then pay to get it printed. I think it's like $2 for using PCB way. That's your first orders. $2 for 5. Well, delivery fee is the one now that it's a lot, but we move. So yeah, that is that. Instead of it, this is a PCB, and then this is now the and then this is now what? This is now the outcome. When you're eventually done without the headers, you really want to solder the headers by yourself. So I hope that makes sense. Yeah. So hopefully when I've mastered it, I'll teach you guys and we'll move from there. Move from there. So yeah, that's what I meant by PCB. That's what I meant by PCB. Instead of using jumper wires, you get to use that instead. Okay, so the next thing we need to look at on the Arduino is next thing we need to look at on the Arduino are the digital pins. Yeah, the digital pins. So the digital pins, as you can see, are these numbered holes on the Arduino. Those are the digital pins. Those are the digital pins. Sorry. Yeah, those are the digital pins. So digital pins essentially what they do. They are they allow you to connect the Arduino. They are the electrical components that allow you to connect the Arduino to digital electronic components. What are all digital devices? I'll just call them digital devices because saying digital electrical components is very long. So what are digital electrical components? So what are digital devices? They are devices that have only two states, just on and off. And because computers work using binary, that's 0 and 1, so they only have two states, 0 being off and 1 being on. All right. All right. All right. So um so they only have two states, on and off, and they have numbers from 2 to 13. The reason why I say 2 to 13 and not 0 to 13 is because this pin 0 and pin 1, if you should connect any devices to them, should you connect any devices to them, right? Like, you may obstruct or interfere with the data that is being sent between your laptop and the Arduino when you're programming it. So I'd advise that you not do that, because you may just be interrupting the transmission and reception of signal or data from your laptop or from your system to the Arduino, or from the Arduino to the yeah from the Arduino to the yeah. So anytime you want to connect the pins, make sure that it is from pins number 2 to number 13. Those are the digital pins. And then under digital pins, we have like other types of digital pins. You can see these ones that have like these squiggly lines in front of them, right? Number 11, number 10, number 9, number 6, number 5, number 3. These are these are um these are pulse width modulation pins. Pulse width modulation. And I can't really go into like the deep theoretical parts about what they are. Let me show you the spelling. Let me show you the spelling. It's even in our curriculum. It's even in our curriculum. You can see it. You can see it. You can see it here. PWM. PWM, pulse width modulation. I can't go into like the in-depth parts of it right now, but I will go deeper in it when we eventually reach it. So let me just explain, since I'm not going to go deep into it. So I'm not going to go deep into it, at least I should explain it a bit. So what is pulse width modulation? Um what is pulse width modulation? As I mentioned earlier, I said that I said I'm so sorry. I said digital pins have only two states, on and off, right? And this on and off states, digital devices, zeros and 0 is off, 1 is on, right? So this pulse width modulation now that we are seeing, what the difference that it has is that for digital devices, it's for scenarios where, let's assume you want to be able to vary the voltage or vary the output of the device. Like for example, for instance now, let's say if you want to increase the brightness of a light bulb or an LED, or decrease it, or you want to increase the brightness of a or you want to increase or decrease the speed of a motor, is for that as well. So pulse width modulation uses this principle of varying voltage, and then it takes the average. But that's, by the way, as I said, when we go deeper into it, we will cover it proper. But it now varies. There's 0 and 1 for digital devices, right? But then for pulse width modulation, now for devices, for cases where you want to use pulse width modulation, it varies between 0 and 255. 255 is the maximum. So if it is going to increase the brightness, or increase the brightness or decrease the brightness of the LED, it will step 1 plus 1 plus 1 plus 1 plus 1 till it reaches the value of brightness I want it to reach, whether 180, whether 200, whether 225, whether 255, which is the highest, which is the brightest, maximum. Or you want to reduce it, you want to decrease, you want to reduce the brightness, it will not be like -1, -1, -1, step, till eventually reaches the voltage or whatever it, till eventually reaches the level that you want it to reach. Till eventually reaches the level that you want it to reach. So that is it essentially. So pulse width modulation, that's it in simple terms. Just it helps you to vary the voltage, or vary the voltage, the value of voltage that is being sent to a digital device, whether an LED, a light bulb, a motor, whatever, whether to increase the brightness, increase the speed, or reduce it. So yeah, that's it for that. I think I've covered everything as far as digital pins go. So now let's talk about analog pins, right? Let's talk about analog pins. As you can see, the analog pins are these pins down here that start with A. The A, of course, stands for analog. right? The A, of course, that stands for analog. So um there's A0, A1, A2, A3, A5. I think on the Arduino Mega is on, so on the Arduino Uno is from A0 to A5. I think on the Mega is from A0 to A9, because they're supposed to be 10, so but because it starts from 0 so to A9. Then I think the Nano 2 is from A0 to A5. But that was by the way. So what is now the difference between digital devices and analog devices? Analog devices now, analog devices are devices that don't necessarily have to use I don't use, let's say, um they don't use voltage or electricity to get their data. Like they use more of mechanical means. Like let's take for instance your digital watch and your analog watch, right? Your digital watches, they have batteries inside of them. Those batteries supply it with a amount of electricity, voltage, current, whatever, right? And then based on how well it has been programmed, how well the battery, how long the battery lasts, how well the battery, how strong the battery is, whatever, like it will work. So then for your analog watches, that's like the watches that have um the watches that have just the seconds hand, the minute hand, and the hour hand, right? Those three, they are now divided. I mean, they are now like differentiated. They are like those three work hand in hand. So if you should open a an analog watch, that's the kind of watch I use. I don't think there's ever been a time, except for maybe like primary school, that I've used a digital watch. Analog, like the classic analog watch now, like classic analog watch now, you would see that they have a combination of like gears inside of them. Yes, they have a battery, but the major principle that is making it to work are a set of gears, how they move on each other. That's what allows the hands to now move and then makes the clock to tick and tick and tick and tick. So they don't work majorly based on, they don't work mostly based on how they've been programmed. They work on how the gears, or how like the mechanical components inside of them work together. And yes, they are powered by batteries, yes. But the major thing inside that allows it to work is not a program that is running, not like code that is running inside of it, but like the components, the mechanical components, the components that don't really require you to program anything, how they work, sort of, if that makes sense. So for instance now, if you have a potentiometer, that's like a knob, right? Let's assume you have a knob. Let me show you. Yeah, take for instance you have like a knob like this is an example of an analog device. And you can see in this image now how it works. Uh they will say, okay, um based on the wiper that is inside, there's like a variable resistance that is working inside of it, and then this is now the track of resistance for that. So based on how the wiper moves, if the potentiometer has maybe a total resistance of 10,000 ohms, 10k ohms, or whatever, you shall see it on the body. But I'm just going in depth. Like now, this does not necessarily have a a means of this thing, a means of, it does not need to be, it does not need to have a program in it for it to work. I can just turn the knob, and then this wiper, based on how I turn the knob, it will be moving, it will be moving, it will be moving, and all of that. When we go into like potentiometers, you guys, like I'll explain how they work. But you turn it, turn it, turn it, turn it, turn it, and then based on that, that's now show, okay, level of resistance between point A and point B, blah 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 blah. Use that to calculate. I don't know if you understand, but they don't work with programs. They work with, let's say, mechanical components inside of them. They can work even without being programmed, more or less. So I think that should be the difference. That's the major difference I can come up with in my head. That's the major difference I can come up in my head. That's the major difference I can come up with in my head. Mm, mm. I'm sorry. I'm trying to. Okay, let's check. So I happen to type it on Google. So what Google says the main difference between this is how they represent and transmit data. They use continuous physical and variable signals like sine waves to represent data, while digital devices use discrete and continuous waves, basically binary that I said earlier, zeros and ones to represent data. So the analog signals are usually smooth and continuous, they vary with intensity, blah 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 blah. Then analog allows for infinite values. So it's not just zero and one, like you have a range of values can increase and decrease. So kind of similar to PWM, but the working principles are not the same. But it's similar, but it's not the same. Then digital devices are more resistant to noise, blah blah blah. So you can see all the differences here. And examples clock, as I said. Yeah, exactly. So you can see the watch now that I use, or clock, anyone. An analog device uses continuous movements of the hands to represent time. Exactly. And then a digital clock runs from one number to the next, representing specific exact moments. So you can see the example that I stated earlier. Then it uses sine waves. Uses sine waves. I don't know. Yeah. So like this, something like this. Sine waves up and down and up and down, then this analog signals, digital signals, just zeros and ones, essentially. So you guys can see the difference. You guys can see the difference. So yeah, that was essentially similar. That was a better way to put it, but that's essentially what I meant. So what's the what is now the working principle of these analog devices? So analog devices have a range of values, right? And this range of values is from 0 to 1023, because as we said, like it's going to give us varying data, varying signals. So that varying data, varying signal is going to be from 0 to 1023. But why 1023? Why 1023? Let's come here. Sorry, hold on. Uh, bum, 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 bum. Okay, I think I should just move up and then zoom in. Okay, so let's come to our board. Why 1023? This one should work. So why 1023? Why 1023? Okay, so let me explain. When we were in school, like let's go to our basic computer science, our basic computer science, well, 1023, right? When we're in secondary, so sorry, when we're in primary school, what we're taught is that um a byte, sorry, a bit is the smallest representation of data that we can have in a computer system, right? That's what we like, how we have our atoms in science, and how they tell us that, oh, that the an atom is the smallest in um the smallest life form of energy, formest sorry the smallest indivisible form of energy or life that we have is an atom. But then they now countered it and said that, oh, inside the atom we have protons, we have neutrons, we have electrons, blah 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 blah. When we were in primary school, they said, oh, that, okay, let me even wipe this, I even made a mistake. They said, okay, that we have the byte, right? We have bytes, and then this byte now is like the smallest representation of data, more or less. But then the same way we have the atom that has like a smaller set of 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 nucleons, abi neutrons, or sorry, of ions or whatever that are inside of them, right? Like the protons, neutrons, the electrons. We also have, inside of bytes, we have bits. We have bits. And in primary school, they said 8 bits will make 1 byte, right? That was what we were taught. That 8 bits is equal to 1 byte, 1 byte is equal to 8 bits, right? So from that angle, looking at it from that angle, from 8 bits to 1 byte, that's the smallest. Bit is the smallest. Byte is second smallest. Because even after atoms, we still have protons, we still have neutrons, we still have electrons inside of them. So one byte is equal to 8 bits. 8 bits is equal to 1 byte. After this byte now, they now told us that, oh, 1 kilobyte. Maybe I should just use my hands. 1 kilobyte. Okay. 1 kilobyte is equal to, sorry, 1 byte is equals to 8 bits. 1, let's just say it's 1 kilobyte, because kilobyte is the next thing. 1 kilobyte is equal to 1024 bytes. After that, we're now told that one after the 1024. So one after kilobyte is now megabytes, right? And they told us that one mega one megabyte is equal to 1024 kilobytes. My bad. 1024 kilobytes. Then after megabytes, we're now introduced to gigabytes. All these are sizes of memory capacity anyway. memory capacity, sizes of data, whatever. Yeah, sizes of data essentially. One gigabyte is now 1024 megabytes, or MB, because writing it seems very long. Or MB. Can also write kilobyte as KB. For those of us who know KB, shameless plug. Then we're now introduced to the last one. There's another one after terabytes, but I'll go into it. We're now introduced to terabytes, and then terabyte is 1024 gigabytes or GB. Mm. And then there's also petabytes. Petabytes Petabytes has to be there are higher ones, but let's just stop here. And there's also petabytes, and then petabytes is now 1024 terabytes also. So you notice, if you look closely, you would notice a trend. You would see, okay, it started from 8, from 8 to cos 1. Then from that 8 now, it's now shifted, and we see a trend of 1024, 1024, 1024. Right? Right? That is that we noticed this trend. So let me go back to the main question that I asked. Why 1023 for analog devices? Okay, so I had to explain all of this first. Before now going into before now going into like the main thing. Okay, so imagine we now want to represent. Let's start from the 8 bits that we started from. Yeah. So imagine we want to represent these 8 bits in like, let's say, a metaphoric storage room in the computer system. So let's assume this is the house, or a metaphoric storage house. Yeah, let's just call it a house. So let's say this is it. This is the house. And in this house we have 8 rooms. There's 1, there's 2, there's 3, there's 4, there is 5, there is 6, there's 7, and then there is now 8. 8 is the final one. I don't know if this one. So there is now 8. There are now 8 rooms. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 rooms, right? And as a human being now, if you want to count the number of this number as a human being, how would you count it? So you start from 1, Abi. You write 1, 2, 3, 4, 5, 6, 7, and 8 as a human being. That's how you would count this number, like this number of metaphoric rooms, of rooms in quotes. But now, let's assume now that you were a computer system, right? As a computer system, you're not going to start from 1, because computer systems take certain numbers that we think do not matter. Computer systems always take it into consideration. And that is the reason why we have binary numbers, zeros and ones. So as a computer, they will automatically always start counting from 0. Computers will always start counting from 0. So if now As a human being now, I count 1, 2, 3, 4, 5, 6, 7, 8. As a computer system, I'll start counting 0, 1, 2, 3, 4, 5, 6, and 7. I would stop at 7. As a computer system, I will stop at 7. They are not 7 rooms, though. They are still 8 rooms. The only difference is that I did not start counting from 1 like normal human beings would. I started counting from 0. And because I started counting from 0 now, that makes the whole difference. And that's the reason why I finished counting the rooms and I stopped at 7. I didn't stop at 8 like a normal human being, because as a computer system, I will always start counting from 0. I will always start counting from 0. So if now, after taking these 8 bits now into consideration, I want to apply that same principle for this 1024 that I see here. I want to apply that same principle. So now, instead of 8 bits, let's say I'm using 1024, maybe bytes, 1024 bytes, 1024 kilobytes, whatever. I now have my house, or I have my memory, which is my house as a computer system. And I now want to start counting to 1024. Human beings will count 1, 2, 3, my different rooms in my house. 1, 2, 3, 4, till I eventually reach blah 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 1024. Share. But then now I'm a computer system and I'm not going to count that way. I will count 0, 1, 2. Let me divide the rooms. Because yeah, 0, 1, 2, 3, and 4. Abi? Keep going till I eventually reach, where am I going to stop? 1023. Till I eventually reach, this my 0, this my 2 is not looking fine. Till I eventually reach 1023. Till I eventually reach 1023. And what this is now going to do, what this is now going to do is that, okay, this is now going to now define, or this should now explain to you the reason why it is now from 0 to 1023 when it comes to analog devices. Digital devices, yes, they have like varying distance, but it will always stop, even if there is 1024 kilobytes, 1024 megabytes, 1024 bytes, 1024 gigabytes, 1024 whatever. The amount that it is going to, the number that it is going to stop at, since we are working with computer system, we're not working with human being theory, we are working with computer system theory, it will always stop at 1023, not 1024, because we are counting from 0. Now, does that make sense? I think it makes sense. Anyway, that is it for analog device. So examples of analog devices that I've shown us before, they are our potentiometer. Oh, sorry, let me share this screen. Yeah, so that should explain to you. That should explain to you at least a certain degree. The reason why is not 0 and 1, or 0 and 0 and this, maybe 0 and maybe 0 and 1, or 0 to 1, or 0 to or 0 to, let's say, 300, or something like that. Like, it will always be from 0 to 1023. So some examples now that we can see, there are, I use the potentiometer as an example. There's also have photoresistors, because we also have photoresistors, we have thermistors, we have flex sensors, we have sound sensors, because all these things, they get data, or they get data based on the sensation, or whatever sensation or whatever simulation that they use. Potentiometers deal majorly with, let's say, resistors, and the resistance of the resistance of the wiper, and how it moves on the resistive track. And then, let's say, the photo means light. So based on the resistance that it detects from light, the resistance changes with light. Then we have flex sensors based on how it is bent on human distance, and temperature sensors as well. Let me see if I can show you guys a few examples. So um these are a few examples. You can see this one. Oh, these are analog sensors, not analog devices, because um they will still use this thing. They'll still use this thing, the digital pins on the Arduino. For sure, you can see the potentiometer here. Potentiometer here. You can see what else? You can see here the photoresistor. This is a photoresistor. Photoresistor dimension that um functions based on the changes of light. It's basically, it uses the light that it detects as a form of to measure resistance, basically. So if light shows on it, the resistance reduces. If there's no light on it, then the resistance increases. So based on the intensity of the light, the resistance increases and decreases. So that's photoresistor sha. As time goes on, we'll go on with them. Yeah, this is a sound sensor. Yeah, this is a sound sensor. So all these things work with like external stimulus, whether light, whether sound, whatever. So examples of sharp analog devices I can use with the Arduino. So yeah, you shall get the point. You shall get the point. You shall get the gist. So that's it for analog devices. That is for analog. And then there's also the joysticks also, because the joystick is also a type of potentiometer still. It's also a type of potentiometer. So I don't know if it's here in Tinkercad. No, we don't have it. But shall just keep it in mind, and we'll introduce it when we work on project shall. So you can see also a joystick here. A joystick here is also part of it. It's also part of the analog devices that can work with. So yeah, because it has like a varying you know how joysticks works now. There's x-axis, there's y-axis. So based on how the knob moves with along the x and y-axis, it measures resistance along that, and then now gives us output signals. So yeah, yeah. So after talking about the analog pins, let's now talk about the power pins. So yeah, let's talk about, so these are the power pins. These are the power pins, right? So we'll start with V in. What is the function and what is the use of V in? So how does V in work? So let's take for instance, when you're working with an Arduino, right? When you're working with an Arduino, there are before you'll be able to program it, or before you'll be able to work with it, right? You need to send a code. You need to send code to it. You need to program it. You need to do whatever it is you need to do. You need to program it, right? So that and now you can now be able to do everything you want it to do based on the project or based on the task, whatever. So when you are doing that, it's going to be connected to your computer system. It's going to be connected to your computer system. And this computer system, I'm so sorry, I'm losing my train of thought. Okay, so when you're working with your Arduino, before you program it, it will need to be connected to your system. On your system, you write the code, and then once you, as you're working with as you write the code, you need to upload it via this is like the code that is connecting it to your laptop, and then it will now upload via here. So you need to work with your system, you need to connect it to your system, and then send the signal, send the code via the code to your Arduino, right? Another instance is powering your Arduino along with whatever component it is connected with, whether it's an LED, whether it's a motor, whether it's a joystick, whether it's a potentiometer, whatever. Like, it is going to be connected to that. It's going to be connected to the laptop, and it's going to be powering the Arduino, and the Arduino, from the power it gets from the laptop, will be powering the other devices, right? So, but then what if, okay, I finished this project now. I finished this project, and as I finished it, I now want to not have to carry my laptop every single time I want this project to work, because it's going to be exhausting. My laptop is heavy. Your laptop is heavy. So why will you at every single point in time want to now be carrying your laptop around at every point in time when you want this project to work? It doesn't make sense. It's counterproductive, because this project is meant to run on its own and it's meant to be portable. So will I be carrying my laptop, or will my laptop be connected to the Arduino at every single point in time? No. But then if I don't want my laptop to be connected to the Arduino at every point in time, I'm going to need a power source. Because after I upload my code, the Arduino will still need a power source. It still needs something to run. And that is where the V-in pin comes in. Like, there are 3 ways of powering the Arduino, right? You can use this USB, this thing that connects it to your laptop. You can use this jack. I will explain what the jack does later. This is a power jack. And then another option is using this V-in pin. I will use this V-in pin for cases when I do not want to have to carry my laptop at every point in time. So I will, through this V-in pin, I will connect the power source, in this case the battery, directly to my Arduino, and it will power it. So there are 2 ways of powering the Arduino without the USB port. First and foremost, I said, is this power jack. How this power jack works is like, it works with a 9-volt battery connector and batteries. Whether batteries or a pair of battery, can be 3.3 LiPo battery, 3.7 volt LiPo batteries, can be a 9-volt battery, it can be 2 LiPo batteries connected in series, whatever. But you will need a 9-volt battery connector. Let me show you what a 9-volt battery connector is. Let me show you what a 9-volt battery connector is. I hope this thing is not producing echo, but let me just show you. Let me just show you what this 9-volt battery connector is. Okay, so let's come here. 9-volt battery connector. Yeah, so this is it. This is a 9-volt battery connector. This is a 9-volt battery connector. And obviously, this part is going to be this part that you're seeing here. This part here is going to be the part that is obviously going to be connected to this, right? This. And then this other part, this part here, will now be connected to 9-volt battery. This part is now the part that will now be connected to the 9-volt batteries. The positive connected to negative, sorry, positive is positive, negative to negative, because you don't want to blow it up. But yeah, essentially, this is how it will be. It will be on top of this, to be mounted on the 9-volt battery. And the other part is now the part that now goes into the power jack of the Arduino. You get? There are other ways, more complex ways that will involve you cutting wires, cutting, attaching wires, tying them together using electric tape and all of that. But we'll go deeper into that later. But this is just it. This is just, it's like just use this. I don't want this to be too different from the original recording that we did. Just use this, connect this to a 9-volt battery, or just cut it, into half and then connect it to a 2S battery, LiPo battery holder, or yeah, something like this, or just cut it, and then like use. Or there are even times where it can come like this. Or you can make your own, like cut it, join it, use electric tape so that it's not, the wires will not touch and short circuit. But you shall get the gist. And then you now mount your 3.7 volt LiPo batteries on top of them. You get, you get. So yeah. Oh my goodness. I just realized I was not sharing this screen. Okay, let me go back. So when I said LiPo battery, 9 volt 9 volt battery connector, this is what I meant, right? So this part, oh okay, it was, I didn't switch back. Okay, so this part will be connected to this part, of course. This part will be connected to this part, and then this part will now be connected to the 9 volt batteries, right? This part will now be connected to the 9 volt battery. Positive, positive, negative to negative. Another thing you can do if you do not want to use 9 volt batteries and want to use rechargeable batteries is that you can get you can just use 2S LiPo battery holders and then cut and join it. I didn't, as I said before, I didn't want this to be so different from the initial recording, the original recording. But like you can get something like this, right? Then cut the 9 volt battery holder, then join the wires together, red to red, black to black, positive to positive, negative to negative. Then use electric tape, right? And then so that the wires will not touch, and then it will short circuit. Then you then connect them together, or you can just buy this, directly. Yeah, there is this one. You can just buy this one. But I've not seen this one readily available. I've not seen these ones readily available, so I just usually just make my own. So you can make your own with the cut and join method that I mentioned before. So I can use this, or I can just connect the positive wire, the positive part of the battery directly to this, because we also have to take into consideration the maximum and minimum input voltage of the batteries, sorry, of the Arduino. If now, for instance, the maximum, I think the Arduino, the minimum input voltage, meaning the minimum amount of voltage that you will need to be able to power this Arduino and for this Arduino to work and function well. That's what minimum input voltage is for the Arduino. But the minimum input voltage for any other for any other electronic component you are working with, you have to check it, and that's is essentially the minimum voltage that is needed for that component to work and to work well, to carry out its tasks and not do nonsense. Then the maximum is not the maximum it can tolerate before it burns, until it burns. So before it burns, so if it goes anything higher than that maximum, it is going to blow, it's going to burn, it's going to like it will die. So that's it, essentially. That's it. So V in now, anytime you want to connect a battery directly to the Arduino, you have to use a V in. You can use either the power jack or you use the V in if you don't want to be connecting with your laptop at every point in time. And then when you are using the batteries, you have to check the maximum and minimum input voltage. So so me now that I want to be a good engineer, I will now type the minimum input voltage of Arduino, right? Minimum input voltage of Arduino is what? It's 5. Okay, the absolute limit is actually 6. It's actually 6, but then it will give out 5 volts maximum, because you can see 5 volts pin there here. We're getting to that goal. You can just see that. So the absolute is 6 volts. Then the maximum is 20. Anything higher than 20, like your body is gone. But it is recommended, it is advised that you do not go anything higher than 12, and you use minimum input voltage of 7 volts for that. Yeah, because why so you can even see it here, why 7 volts? The onboard 5 volts regulator needs a minimum voltage around 6.2 to efficiently step down to 5 volts. That's the 5 volts that the chip uses. That's the microprocessor. So supplying too little, like 5 volts via the jack, can make the regulator work hard, and then generate heat. And your board may or not work at all. So rather better you just supply 7 volts or 6 volts, or recommended 7 volts. Recommended 7 volts. So you can see, connect the positive part of the battery of whatever power supply you're using to the V in, then connect it to ground, because as I mentioned earlier, okay, yeah. So now let's move to ground. What is ground? What is ground? You can see like 3 symbols here: GND, GND, GND. You can see them here: GND, GND, GND. Of course, they'll be black, because will it be princess if it's not color coded? GND, GND, GND. So you can see all these GND, 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 they are ground, right? And they stand for ground, they mean ground. And what is ground? Ground essentially is the part of a circuit, is the part of the circuit that completes the circuit, or the part of the circuit that, essentially, let's just say, is the negative part of the circuit, of a circuit. For lack of better, I will explain better, but in summary, let's just say that ground is like the negative part, or the earth part, the negative part of a circuit. Like now, let's use, for instance, let's come back to our mirror board, and let's carry this away. So imagine we have a circuit. Let's use the circuit we used when we were explaining voltage, current, and all of that. So this is my battery, this is my LED, this is my resistor. Then I'm sorry that this drawing is very small. And then this is my ground. Right? Okay. LED symbol is not complete without the arrows. This is arrow 1. This is the arrow 1. This is the arrow 2. Please don't mind my drawing, I beg. Please don't mind my drawing. So yeah, this arrow. So this is my battery. This is symbol for battery. It's actually supposed to be neater than this, like this. Shall just know long short, or short long short. So shall just like bear it in mind that it's like 1, 2. Sometimes depending on the number of cells. Yeah. Well, let's not go into that. So this is the battery, this is the LED, this is the resistor. I apologize for my ugly resistor, and this is ground. So this is negative positive, negative, positive. Remember, the side with the long stroke is the positive part. Negative, positive, right? Negative, positive, negative, positive. This is it. And then this is the resistor. Resistor does not have polarity. I mentioned that before. And that means that it does not have polarity, meaning that there's no positive, there's no negative. You can connect any leg of it to anywhere. So we're good. So negative, positive, negative, positive, and then goes to ground, and then the cycle continues and continues and continues and continues. Yeah, the spiral continues. So this this ground parts, this circuit cannot be complete without this ground, because if this ground is not here, current may not know where to stop or to continue from. Let's say like ground is the end point of any circuit. Like, yes, the electricity will keep flowing and flowing and flowing till you eventually like unplug the power source, remove the power source, or turn off the switch if there is a switch. If there was a switch here now, like you would have seen, if there was a switch here now, you would have seen this thing. There was a switch here now. You would have seen this thing. You would have seen maybe something like this. Open, open, open. Oh, like, let me just draw it outside of that. Something like, okay, this is it. Then like this, then this, then this. It's connected. So there is like a gap in between them. So once this part touches this part, like closes, the current now flows because there's no gap in the this thing. There's no gap in the circuit. Well, let's not go too deep into that, because as I said, I don't want this first recording to be different from this second recording to be different from the first one, right? So go here, go here, and without this part, the current may not know its initial. Yes, like the electricity is starting from the battery, but it will not have like a reference point. So the ground is like a reference point for any circuit, and without the ground, the circuit is not complete. Like, let's take for instance, right? Like, it is the part that essentially neutralizes the circuit and stops it and prevents it from going haywire. If it prevents the electricity from going haywire. How does that happen? Let me explain. So we know, like, all these very, very big trucks around, right, that carry diesel, all these diesel trucks, all these diesel tanks, and all of that. We know that they travel very large, very long distances, and a lot of times, like, when they travel not with water. They travel carrying petrol, diesel, kerosene, different things, sha. But if you understand chemistry very well, you understand that these liquids or these fuels that they are carrying around, they have some set of ions inside of them, positive ions, negative ions, and as they are moving around, like, these ions are bombarding each other. Let me show you something. Let's come here. So diesel trucks. Ah, this is not. Uh, okay, yeah. So look at something like this now. As they are carrying them around, I don't know why these things are so tiny. But use this as example. As they are carrying them around, they are carrying like petrol, fuel, kerosene, everything. And as I said, if you understand your chemistry very well, you understand that a lot of things are going on as they are moving. A lot of things are going on as they are moving. Like they are they are as a lot of electrons, a lot of protons, they are bombarding into each other. I think they are mostly negatively charged, I think. But a set of like protons, electrons inside of them, like they're bombarding each other, they're bombarding each other, they're bombarding each other, bombarding each other. They're also hitting the corners of the tanks, like the corners of the trucks, like the tanks, like the walls of the tanks. They are hitting them, they are hitting them, and they are hitting them. And as they're hitting them, they are discharging, they are sending out some charges. They are sending out some charges. And a lot of times, like if care is not taken, right, and then there is no way of neutralizing all these charges that are being generated inside of them, this tank is going to explode. This tank is going to explode. And that's the reason why like they are so sensitive that if you if you come too close to them, I kid, like you come too close to them, tiny spark or tiny this. I think that's the reason why they tell you that when you're going to petrol stations, like when you're going to gas stations, petrol stations, that you should make sure that you keep your phone as far away from distance as possible. Your phone has charges. This petrol too has charges. So if they now bombard, I promise you something is going to explode. Your phone is going to explode, or this thing is going to explode. That's the reason why they used to say that, oh, you should not receive calls in gas stations, this thing, because it may trigger something, and then an explosion may happen. But then, so for these tanks now, as they are moving around, moving around, moving around, all these things, like all these petrols and everything, they are they are bombarding each other. And if care is not taken, if there's not a way of neutralizing them, these things are going to explode. So what do people that now construct these tanks, what did they now do? They created a chain. They created a chain that is going to do the work of ground. But in this case, it's not, it can connect, you can call it connecting to ground or connecting to earth. Earth as per EARTH, earth. So connecting to ground, connecting to earth, right? You will see that when you look very closely at the bottom of um these petrol tank trucks, when you look at these petrol trucks, right? Like when you look at them very well, you look at their backs, you will see that they have something like either a rod or a chain that is touching the ground. If you look very closely now at this one, you will see it. You see it. Like you can see this rod now. I want to look for one that is more. I want to look for one that is more distant. I want to look for one that is closer. Mm, let's just use this one. So you see this chain now. You see this chain. Like this chain is acting as a neutralizer for all these charges that are being generated. All these charges are being generated in this thing, right? All these things that are being, you can see now, all these things that are being discharged, like all the charges that are mounting up at the walls of these tanks. What this chain does is that it helps to neutralize it. It helps to neutralize it so that there will not come a situation where okay, something is this thing, the charge builds up so much and then the tank now explodes. It's going to be very dangerous to the driver. It's going to be dangerous to the people that are driving around, that are driving close to the distance, that are driving close to the that are driving very very close to the truck. Like it's going to be very dangerous. So you can even see it. um why is it that this is, I've said, it prevents static electricity buildup as the truck moves. Friction between the wires, The metal chain touches the ground, creating a path for static charge to safely dissipate into the earth. You can see that, like, there are other reasons, but this is like the main reason that I want to emphasize. If not for this chain now, there are going to be so many cases of, oh, this tank was moving and then it blew up. So this chain is acting like a neutralizer, all the charges, because the earth now, I think the earth is immune to all of this. So when it sends it to the earth now, nothing is going to happen to the earth. The earth is already charged, provided it travel to the core of the earth, and it will be neutralized before it even gets there, because the earth is very deep, very, 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 very deep. If you remember our geography well, we have the, I think, the part of the earth, the lithosphere, stratosphere, all of that, that shall before we that shall make up like the different layers of the earth, right? So these charges will travel to the core of the earth, and by the time it travels to the core of the earth, but before it even reaches the core, like, it would have dissipated, like the charges would have already calmed down and reduced. So that's the reason why we have earth. And even sometimes, like, you talk to some people, they will call ground earth, because it's serving as a neutralizer for all these charges, so that they will not go haywire in a distance. So what this ground does is that it completes the circuits and prevents, like, all the charges from going haywire. So yes, like, okay, there are negative parts of the circuits. You connect the positives to the power source, yes. You connect the negative parts to the ground. So that the reason why I call the ground the negative part of the circuit was because you connect the negative parts of the circuit most of the time. Connect it to ground. Connect it to ground, because I consider ground to be the reference point. I consider ground to be the negative part. I consider ground to be the neutral part also. So that is the function of ground. It completes the circuit and it neutralizes the charges so that the electricity flow is stable, if that makes sense. Yeah. So the electricity flow is stable. Then let's come to 3.3 volts and 5 volts. 3.3 volts and 5 volts serve as power supplies for the components that you're connecting it to, whether analog components, whether digital components, the electronic components that you're connecting the Arduino to in your project. That is what 3.3 volts and 5 volts do. They serve as the power supply. So when do you use 3.3 volts? When do you use 5 volts? For most of them, you can use 5 volts. But 3.3 volts are for, let's say, an instance where you're working with two devices, and then you need to connect both of them to power source. Maybe one requires 5 volts, and then the other, it can vary, but you can manage with 3.3. You can use 3 volts in that place, or you can work. Or there are some devices that are very, very sensitive. Like, for instance, let me show you. There was one component that I used. There's one component that I used. Uh, there was one component that I used. And this particular component now, if you look at it, there are some components that there are few, but there are some that you will need. You can't use 5 volts, if not they will blow up, they will burn, right? Because they are that sensitive. So for example, an example is this NRF24L01. There are components like this that don't need 5 volts. 5 volts will be too much and it will burn them. So you can see now that if you check the specs, you see that the operating voltage is between 1.9 and 3.6. There is no 1.9, there's no 2. The lowest we can see on the Arduino board is 3.3. So in this case, when you're working with this kind of component now, always make sure, for you to be a good electrical engineer, or for you to be a good embedded systems engineer, you must always look at the specs of the components you're working with. Check your data sheets. Your data sheets should be your best friend. Check your data sheets. You can check the internet, maximum and minimum voltages of every component that you're using, so that there will not be a situation whereby you are working with one and then the voltage is too much or is too low. and then it doesn't work properly, or it's too much and then it burns. You don't want a situation like that. So always make sure like check the operating voltages, operating current, maximum power consumption, everything that you are going to need for the component, so that they will not burn, and you know which pin to connect them to. So in this case, for the NRF 2401, this is like a radio frequency transmitter and receiver. Yeah. So operating voltage is 1.9 to 3.6. So in this case, we were going to use 3.3 on the Arduino. Another example is the RFID card reader for Arduino. The RFID card reader module for Arduino. So for those of us who are familiar with this, for those of us who have seen it, this for like taking attendance, using this sometimes used in attendance systems, sometimes it's used in, let's say, automatic door locks that have like a card. Like when you go to like all these fancy hotels, sometimes they'll give you a card instead of a key. You use the card reader will read the card, and then the door will open. So this is like a, for if you want to run a prototype kind of thing. So this is the RFID card reader, the card and the tag. The tag does the same thing that the card does. So in this case, you there is, trying to show you the maximum, the operating voltage. So in this case now you see uh mm, so in this, see, yeah, you can see the RFID card reader module voltage varies, but popular one runs on 3.3. More industrial ones use wider ranges like 2.25 or even this. But for this module now, primarily they use from 2.5 to 3.3 range. So most times I will always advise that you just use 3.3. If you are using this RC522. Yeah, if you are using that, just make sure that you use your 3.3 volts, so that the chip on the board will not burn, on the reader will not burn. So you shall get. Yeah, so this is an example. This is an example. So, and then some other components now that may require like 5 volts. Some require 5 volts, some require more. The ones that require more, you need to use like external power supplies or whatever. Like a 7 now, for example. 7 now, usually, servos will, they need like very high, yeah, like they'll need like around 4.8 to 6. Then the very high ones, that's the heavy duty ones, sometimes they'll need 7.2, sometimes they'll need 12, say sometimes they'll need 12. So you'll need like higher power supply. So whenever I work with servos, I'm just using this as an example of a component that you can use 5 volts for. So whenever I use a servo, most times I use, all of the time, I won't even say most time, all of the time I use 5 volts, because I know that it has more weight, carries more weight than, let's say, all these let's say LEDs or whatever. For an LED now, the only difference if you connect 3.3 and 5 volts is if let's say for instance, the only difference would be that, oh, it will be brighter for 5 volts than it is for 3.3 volts. But remember what I told you in the last class, always make sure that you connect your resistor so that your LED will not blow up, because sometimes 5 volts is too high and the LED will not blow up. Like the simulation that I showed you guys, that I showed you last time. So yeah, that's 2.3 and 5 volts. Then this reset pin now. This reset pin is for like situation where you use it along with other pins for situations where maybe your Arduino has virus or is malfunctioning and you want to flash your Arduino. Like the way you flash your phones, like you completely wipe the data on your phones. You can also do that for an Arduino, because at the end of the day, it's still like a small computer, even though like it's a microcontroller, or you can still flash it, you can still wipe the memory, right? You can still wipe the memory. And for those times that you want to do it, you are going to need the reset pins along with other pins. You can't see the pins because Tinkercad will always like show, it will omit some parts, but let me show you. Let me show you now. Okay. So on this Arduino now, for instance, on this Arduino, you can see these pins here. And you can see these pins here also. You can see them. Like, and then you can now also see, let me show you one that is more close up. You can see it here. See it here now. These pins here, these pins here, these pins here, these pins here, and the reset pin. They work hand in hand. They work together. When you want to flash your Arduino, or even when you want to flash your Arduino, when you want to flash your Arduino, when you want to install the bootloader. Bootloader is like the OS, the operating system of the Arduino, because this is not a computer, it's a microcontroller. So you want to burn the OS into it. You need these pins. You want to flash your Arduino, you need these pins and the reset pin. So yeah, that's what the reset pin is used for if you want to flash your Arduino, something along those lines. And you can see on this thing, you can see how beautiful this PCB is. You can see how beautiful this PCB is with all the other components attached to it. So Tinkercad will not give you a detailed image like this, but you guys shall get the gist. Like, you shall get the gist that this provides like a more this provides a more detailed look on what the Arduino board looks like up close. So now let's go back to Tinkercad. So that's it for the reset pin. Then the which other one have I not spoken about? The input, the IO ref, and then the A ref, right? So I was in the IO ref now. It stands for input output reference. The input output reference pin, right? So input output reference pin, meaning that let me give you a simple explanation. What this pin does is that it provides a reference voltage for, let's say, Arduino shields whenever you attach it. So let me explain. There are sometimes that you are working on projects and the Arduino board alone is not enough for you to use. And you will need, because of ease, because at the end of the reason why we are doing everything that we're doing in tech, in hardware and everything, so that we can make work easier and we can make it faster. There are times when you'll be carrying out some certain projects, and working with the Arduino alone is limiting. In that case, you may need to work with certain Arduino shields. And these shields, what they do is that they serve as extensions of the Arduino board. And they increase the functionality, the capabilities of the Arduino and of the project that you are working on. So let me cite a few examples. They are like, let me show you a few examples. Like this one now. If you want to increase the pins now, because if you look at this Arduino, there are only so many pins. But there are cases where you work with shields, and it will increase the amount of pins that you can work with on the Arduino. Sometimes if you are working with motors, you may need a shield like this. This is called the L293D motor driver shield. There are different types of Arduino shield. You have this multi-purpose V1 shield. There is which one again? There are different ones, and what they do is that they increase the capabilities of the Arduino. So let's take, for instance, you're working with this, and see now there's another one. There are also several shields too for the Arduino. There are different types of shields depending on the tasks or the project I want to carry out. But let me use this L293D now, this motor driver shield, as an example. So when I mount this, because when I look at these things, there are pins underneath, right, that will allow me to be able to attach it to these pins. Because you can see that these are female headers. These are female headers. There has to be something that will allow me to be able to mount these shields on them. So underneath these shields, there are other pins too. You can see these pins here. You can see these pins here. There are other pins that will now allow us to be able to attach them. That will now allow us to be able to attach them to these Arduinos, right? That will now allow us to be able to attach them to these Arduinos. So what they do is okay, when I mount them, when I mount this shield, for instance, as I said, I'm using the e.t.c as reference. When I mount this e.t.c on my Arduino, there needs to be a reference voltage, a range of voltage values that this thing will be working with, a reference voltage, right? And that is where this input output reference pin comes to play. So it is going to tell the shield that, okay, this is the voltage level, or this is the range of voltage level that this Arduino Uno is using, or that this Arduino is using. Work with it. And that is what this input output reference pin, this IO reference pin, that's what it does. It tells it that, oh, these are the range of values for voltage that we are working with, that this Arduino is working with, oh, and that it gives off. For example, 5 volts. The Arduino is working with purely 5 volts voltage logic. As it's working with 5 volts, this shield, don't go and be using 12 volts. So don't go and be demanding 12 volts, because the Arduino does not have it. Don't go and be demanding 7 volts, because the Arduino does not have it. It is providing and working with purely 5 volts. So that 5 volts, work with it. That 5 volts, work with it. The 5 volts, the 3.3 volts, whatever, like, work with it. So let me show you. Now, this is the Google definition. So it tells the connected shield what logic voltage level the board uses. For example, 5 volts for the Uno, 3.3 for the Due. I told there are different types of Arduinos. The only difference is just their sizes. They have the same architecture. They have the same same working principle, more or less. Just the sizes and the designs are different. So this now, I'm using 5 volts. I'm using 5 volts logic. Please don't use anything other than that. So that's what it does. It regulates and gives a reference voltage for these shields to work with. And then there is now the analog reference pin. So what this analog reference pin does is that, Jesus Christ, have mercy on me. Okay, so what this analog reference pin does is that it provides an external voltage source to define the maximum voltage. Okay, let me just show you where I'm reading from. So analog reference pin on Arduino provides an external voltage source to define the maximum voltage for analog to digital conversions, allowing for more precise readings, especially if the signals to use that even. Essentially, what it's saying is that whenever there are some things called analog to digital converters, right? There are some things called analog to digital converters. And what analog to digital converters do is that they change or convert analog signals to digital signals. The analog signals, when I was explaining analog devices earlier, I was saying that analog devices have like a sine wave kind of logic, and then digital devices just have 0 1 0 1 0 1. It's kind of like in a straight line. That's how digital signals are. And then analog signals are like up and down and up and down, like that sine wave we saw earlier, right? So what this analog reference pin does is that it provides an external power source. It provides an external power source so that when the Arduino, because the Arduino has an inbuilt analog to digital converter, so it has a converter that will allow it to change analog signal to digital signal, change digital signal to analog signal. That's the reason why analog electrical electronic components and digital electronic components can work on the same Arduino board. Like you can work on the same Arduino board. Analog signals are being converted, digital signals are being converted too. So when all of this is happening, the analog reference pin provides a an external voltage source to define the maximum voltage for these things. So now, if when the analog to digital conversion is now taking place, right, it will do it at a certain voltage, and that voltage that it provides will now be the reference voltage for when this operation is going on. So they said to use it, you must connect your stable voltage source to the RF and then set the reference to external using, you have to program it, but like you have to program it, but if you are working with like external device, like a component, and you need a stable voltage source, right? Like, how do I even explain this? Mm, hmm, okay. Depending on the component that you're working with, right? Depending on the component that you are working with, what this ARF pin does is that whenever you connect this, whenever you connect whenever you connect a certain component, right? Or we just give me a second. Give me a second. Give me a second. Just come back here. Just give me a second. Okay. Okay, I think I've gotten it. So what it does is that, as you can read from here, it allows you to feed the Arduino a reference voltage from an external power source. So let's say, for instance, you're not using your laptop, you're not using you're using a battery, an external power source instead. And you want it to be that, as it is doing that, as you are providing the Arduino with an external power source, I want it to be that I give it a maximum voltage to work with when it is powering this Arduino. I'm going to connect it to my analog reference pin, my ARF pin, right? So when, as this says, for example, if you want to measure voltages with maximum range of this, you find a nice smooth 3.3 volts into this, and then use probably perhaps for this instance. So when you are doing these things, it allows you to be able to work with a certain voltage. When you are using an external power source, it will allow you to use a reference voltage that, okay, as you are working on this Arduino, as I'm using you and I'm working with this Arduino, maybe, okay, I know that you are working, I know that the okay, if we want to measure voltages with a maximum range of 3.3, right, we should feed a nice smooth. So based on the voltage that this power source has, we are going to use that voltage now as as we are going to use that battery, this power source. Maybe it is 9 volts, maybe it's 3.3 volts. If we're using 9 volts, we connect and we want it to be that the voltage now that this Arduino is using, we want to make it 9 volts, right? We are going to connect it to, because we know originally it uses 5 volts. Originally it uses 5 volts, like it converts, even if it uses, like maybe even if you connect, like let's say a 12-volt power supply, the Arduino will still step it down. You still have like um a step down circuit, like that will still step it down and make it work at the original this thing, which is 5 volts. But then when you're using this aref function, it allows you to feed the Arduino with a reference voltage from the external power source. So if we are using this thing, if we are using another power source, instead of it using 5 volts that the Arduino is used to, connect it to the aref pin, the analog reference pin, and that will be the reference voltage that the Arduino uses throughout. Do you understand? I hope that makes sense. I hope that makes sense. If anybody has any question, can just ask me in the next one. So will ask me in the group chat. And yeah, ask me on the group chat. But yeah, that's it for aref. So I hope I've been able to do justice. I hope I've been able to explain. I've explained what the power jack is used for. This is the USB port that's using the cord. Let me show you the cord. This is the cord. This is the cord. So using this cord, this part, I don't know why it always shrinks. This part is connected to your laptop, and then this part is connected to the Arduino. So this is the USB, this USB part, this to your laptop, this to the Arduino. So this part, that part that connects to the Arduino, this is where it now connects to. Then this reset button, what the reset button does is that, let's say when your RAM is running slow on your phone, you look at all the tabs and you will close all the tabs on your phone, right? Or let's say, oh sorry, okay, so I was saying that that part is the part that connects to yeah, that this is the part that part connects to on your that the Arduino, that connects to the Arduino after I've connected it once from your laptop. Yeah, that allows you to upload the code. Then the reset button now. The reset button is like, okay, let's take for instance your um it's like whenever on your phone, let's say the RAM is full, or the RAM is full for whatever, the RAM is full. So sometimes you'll be like, oh, you have too many apps open, you now close all the apps so that the phone will start running like smoothly. And or maybe on your laptops, your computer system, maybe you have too many tabs open on your Chrome, or you have too many apps open, or whatever. So you close them, then you refresh so that at least like the RAM of the system will not be too packed, and then it like starts running smoothly again. So that is like kind of the same thing. That's the same thing that this reset button does. It basically like resets the RAM. It doesn't wipe the code. It just like clears the cache memory, and then like restarts it, and so that the code can run more smoothly. Yeah, run more smoothly on the system. So that's the function of reset, but just like clearing your RAM, like clearing your tabs, your open tabs on your system, so that on your phone, so that it can be fast and run more smoothly. So it's like a way of restarting your code, or yeah, refreshing the RAM, restarting your code on the Arduino, sort of. So yeah, that's the work of the reset button. Then the other passive things, the oscilloscope capacitor, sha. I will talk more about it in the next class, but that is it basically for introduction to the Arduino board, for the Arduino board part. So now let's look at the next thing on our curriculum, and after we are done with the Arduino board, the next thing that we're supposed to cover is the Arduino IDE, and that's where we'll stop for this class. So the next thing is the Arduino IDE. So we are actually have used up a lot of time, so I'll quickly brush through it. I'll quickly rush through it. So the Arduino IDE. So I think I have the one of the latest versions on this system. So I want to try to open it now so that I'll show you guys what the Arduino IDE is all about. Okay, so let's just wait. Let's just wait. Okay. No, it is still loading. Mhm. Okay. So saying mm, mm, saying the ID has opened. I don't know why it tends to take a while to load up this particular version for certain laptops. I don't know why. But let's wait. Let's wait. So IDE, Arduino IDE. So IDE stands for Integrated Development Environment, right? IDE stands for Integrated Development Environment. And what it does is it basically serves as the software for writing all your Arduino code, um, all the projects that you want to work on, testing the Arduino with components, all the different things, different things. So basically, it's the software that you use to program your Arduino and program whatever Arduino project that you want to work that you want to work on. You can accommodate other microcontroller boards, right? There are different types of Arduino boards, but you can still like work and accommodate other types of Arduino boards, other types of Arduino boards like sorry, other types of microcontroller boards like the ESP32. I think you can use I'm not sure if you can use Raspberry Pi Pico, like the smaller versions that are like the Nano. I know you can use some Spark phone microcontrollers also. So there are different ones, sure. There are different ones that the Arduino can use. There are different microcontroller boards that the Arduino software can use, or the Arduino IDE can use. Why is this thing taking so long? Let me restart it. Let me start it again. Hopefully, it doesn't take as long. Very good. Very, very good. Okay, so it's asking me to download a new version. So the latest version is version 2.3.7, but I want to skip that. I beg. If we are going to update it, it's going to take time. So I'll just skip it. Not now. Not now. So let me show you what the Arduino is all about. So this is the Arduino IDE. And as I said, stands for Integrated Development Environment. Is the software where you write your Arduino code and upload them and run them. You want to see data from the Arduino and see it on the serial monitor, or you can get a screen on with the project that you're working on and then work with it. Yeah. So there are different just going to run through all different parts of the IDE, and then the next class you can start understanding Arduino programming, then start working on minor projects proper. So the Arduino IDE um, I'll start with all this first, then I'll go to the code. So we have this part. This is sketchbooks part. This for new sketches, for creating new documents, new code documents or new distance. Like now, okay, if I click new sketch, it's going to open another window for me to now write another code. But I do not want to do that, even though it has already opened. Even though two have already opened, but I don't want to do that. So new sketch is basically for when you want to open, like how you press Control N on Microsoft Word, something like that. Like new window, new code, new page. Yeah, so that's what it does. Then this is for Arduino Cloud. That we'll use this when we're working on IoT with Arduino. So this is for Arduino Cloud, sign in, then you see all your cloud sketches, Arduino cloud sketches, and sync them and all of that. Then this is the board manager. I said that the Arduino IDE can accommodate the Arduino as well as many other boards. And I also mentioned that there are different types of Arduino boards. So because these are the default ones that come with, you can see Windows 10 IoT Core, can see Intel Curie boards by Intel. You can see so many different boards. You can see tiny bits Arduino AVR modules. Yeah, you can see ESP32 also. So that's another one. You can see Arduino Uno Q. For those of you who don't know, Arduino Uno Q is the latest and newest version of Arduino that is out there, and Arduino apparently sold company to Arduino sold their company to this to Quad. I've forgotten how to pronounce their name. I think Quad. They sold their company, or they did a collaboration with it. They did a collaboration, Arduino, yeah, Quadcom, thank you. Yeah. So it's like a collaboration between Arduino and Quadcom. And in the process, they created, or Arduino sold her company, and they created, what did they create? They created, ladies and gentlemen, the Arduino Q. And if you are, let me show you. You are very, you know, like one or two, what happens in the tech world, you would have seen it somewhere. So the Arduino Q, the Arduino Q, yeah, so you can see it here, the Arduino Q. Bigger, better, faster, more capabilities. Crazier. I don't even think it's right for it to call this a microcontroller anymore, to be very honest. I don't think it's right for it to call it an Arduino Uno anymore. Oh yeah. Oh, you can check it out. You can check it out yourself. You can check it out yourself. You can check it out yourself. Let's go back. So let's not get distracted. And check it out yourself. So now I'm the one that's getting distracted. I beg. So yeah, that's the Arduino Q. So let's go back to the Arduino. Yeah. So I was saying the Arduino Uno Q, the Arduino Uno, Arduino Mega, different board libraries, essentially, like different board libraries. Arduino ESP32 boards. So these libraries will accommodate all the different types of Arduinos that fall under that category of the board. So this is it. So you can just come here, type whatever board you're looking for here. Maybe I'm looking for ESP32. Come here, download ESP32. Why do I talk about ESP32? So after Arduino, we are going to learn ESP32, especially with IoT and other things. Then this is now the library manager. So for certain components that you work with in the Arduino, you will need to import libraries. What are libraries? Libraries are like compilation of codes that in one place that allow you to run certain setting that allow you to be able to work with certain electronic components, right? That in certain electronic components that do not that the Arduino itself do not naturally does not have the prerequisites to carry them, or to allow them to function, or to allow them to move, or to allow them to carry out whatever task it is you want it to carry. So an example, I always use the servo, because after LED blink, next thing you're going to learn, one of the next few things you're going to learn is servo. So these are different libraries. You can search for any of them. I've showed you. And search for any of them. There's a servo library. There is brushless. You can see brushless servo library here. You can see DIY, DIYables, different things. But now I want to look for the servo library. So I'll just scroll down because this thing doesn't seem to be working. So I have found the servo library, I believe. So usually when I select it, when I type it, it shows me like different ones. But I'll just I'll pick one of it. So I'll pick servo motor module. I feel like there is another one I'm supposed to. I don't think it is this one. Well, that's it. That's it. So how do I now import this servo library? I will write hash include. That's how I import. That's how I import. Then the name of the library, I put it inside this greater than less than sign. Then based on how it is I want to use, I have to write, declare an object, call it, give that object a name, and da. Then say whatever this thing is connected to. So basically, libraries work with different electronic components that the Arduino would not have originally had the capacity to carry. Make sure that you import them so that these things will be able to. Okay, so it's here already. Seven. Excuse me, it's usually the first one. So as I typed it, it actually came out. It was not acting like it was not listening to me. Anyway, servo by Michael, that's the library. So I import it. When I restart it now, you see that this particular servo here will be orange because there's color code and then that color code essentially shows that this thing is working. Essentially shows that the library is working or has been activated. So when you see that color, it may not apply in all IDs, but it may not apply in everybody's IDE, but that's it essentially. This will turn on. You can see that both of them like they are highlighted. This will turn orange, this will turn orange. So you know that it's activated. If I restart the ID now, you see it. But because of time, let's just save time. So you come here, import the libraries you want to work with, depending on the distance. That will require deep research, but based on the example codes that you want to see, depending on the components that you're working with, you'll be able to see that, oh, okay, this will require a library. I need to download this library, this and that, this and that, this and that. So as a beginner, yes, you learn to write code from scratch, but sometimes as you progress, you will not really have the time. But as long as you understand the code, like that's the most important thing. As long as you understand every line in code. So this one is for debugging. There's no board selected, so it can't debug. It doesn't know what to debug. And this is for search. Maybe there's something in your code you want to search for. Search servo. So I will now here it will now appear the different instances that servo, the word servo appears in my code. So you'll see it here. Then yeah, so that's what this magnifying glass icon is for. Then I come here. This is for file. These are the different tabs. We have file, edit, sketch, tools, and help. So file is for creating new sketch. Creating new sketch, as I mentioned before. Create a new sketch, new Arduino code page. Create new cloud sketch. I already explained that before. Open an Arduino file, probably one that is saved in your system. Look for it and open it. Sketchbook, like it show you that. Then the examples are basically example codes based on the library, sometimes based on the library, sometimes inbuilt. Some of them have like this one now, for example, you see examples, you see basics, you see bare minimum, sometimes you see led blink. Now this will now show you like a beginner, like a simple example of a simple LED blink code example. Oh, sorry. Wait, what have I been showing you guys since? I know I have not been doing rubbish. I have not been doing. I hope you guys have been seeing what I've been seeing. If not, it's not going to be funny. It's not going to be funny. I really hope you guys have been seeing what I've been seeing. Okay. I really, really hope you guys have been seeing what I've been seeing. So yeah, let me show you. This is the LED blink example code. So here you see blah blah blah, turns an LED on for 1 second, then off for another second. This and that, this and that. So you see example, delay on for 1 second. When I'm explaining, when we're doing introduction to programming, I'll explain more about it, but this is it essentially. Example code for blink, LED blink. There's also example code for servo sha. Um there's also example code for servo. Um Example code for servo. What it to do is if I eventually go through, so there are two examples, knob and sweep. Knob is basically allowing you to control the angles of the servo with a joystick module, with a potentiometer. Like as you turn the knob, the servo changes position, blah blah blah. So this is another example code. You find it in examples. This is another example code. So you can see it here. So you can see it here now. I'm so sorry that this class is actually taking more than I anticipated. But yeah, for some reason I can't show you. So yeah, you shall see blink. So that's the major thing. You've seen an example code already. So moving on. Yeah, moving on. Moving on. So the next thing afterwards is okay. So in preferences, I don't even in preferences, I just wanted to make sure that you guys are seeing what I'm saying. Okay, so in preferences will show you, okay, where do I want, when I save my code, where do I want my code to be saved to, where do I want it to be saved to. Then I can browse it, I can change it, I can select like the different places that I want my this thing to be saved to. If I don't want it to be saved to document, I can change it, save it to downloads, do like, let me just make sure that you guys are seeing what I'm seeing. Okay. Okay, you guys can't see, but like if I select a different location, you know, like how, like if I select a different location to choose it, and then you see that it has changed, downloads, recorded classes. But I want to, let me just change it back. So documents inside Arduino, that's where I choose. That's where I want to save it. So where do you want to save it? What font? What this thing? What theme for your Arduino? This thing. A lot of people prefer to use dark theme, sure. What language do you want to show what goes on when it is compiling and uploading? It's very messy but very very interesting. Compilation warnings, non autosave, blah blah blah. Then this part for additional board URLs is for maybe situations whereby you don't want to use the board manager, or you have a board that the board manager does not have it, and you want to work with it. Sometimes like there are two different ways that you can install it on your IDE other than having to use the board manager, right? You can go to, let me share this part. Uh, let's go to the part that has Arduino Q. So what I'll do is that I will type the board. Let's say for instance is the Arduino is the ESP32 that I want to use, that I want to get its board URL, right? So I will type ESP32 board, and you can see board manager URL. So I'll scroll down. Either I copy this link for the JSON file. Sorry, I copy this link like for the JSON this thing. I copy it and then I now paste it. Inside my that preferences thing that we saw before. I now paste it. Inside here. This additional board, and I'll paste it here. Either I copy that and paste it here, or sorry, let me go back to preferences. Or I will I will come here. Let me show you. I will come here. I will scroll down. I will go to GitHub, because GitHub is the most reliable that I know. GitHub has practically everything. And then I'll press code. You can see all the instructions, everything here. And you can see that the URL is not different from the one that we just imported there before. Like they're kind of similar. There's not so much difference, like the URL here. So yeah, you can see it starting with blah blah blah. These are the instructions, sure, but I already know what to do. So I'll come here, press code, then come here, press code again, press the drop down arrow, then download zip. After downloading the zip, right? Once the zip file is downloaded, I will now extract it. And then after extracting it, after extracting it, after extracting it, we have it. After extracting as well, I hope we all know how to extract in this thing. I hope we all know how to extract. Well, anyway, that's. If we don't, that's fine. So after extracting it, let me just quickly show you how to extract. Once you download it, let me show you. Okay, let me share my screen. I'm so sorry, I'm getting distracted a lot. So these are my downloads, and then I would come here. Let's then double click on it. Then after double clicking, I would now say okay, or I would now say, or I would just right click on it, and then you would see this thing, extract all. Oh no, sent me to right click. I can still right click, click on extract all. Where do you want to extract it to? I want it to be outside of this thing. So I'll put in my downloads. So select folder, I extract it to downloads. So once I'm done extracting it, once I'm done extracting it, so this is, once I'm done extracting it, right? I It's still extracting, but let's save time. Let's save time. So let's assume is this one, this soil monitoring device key, and then I right click on it, I extract all. I want to extract it to my downloads. I extract it to my downloads, I select, I extract, then it finishes. This one is lighter, so it will finish on time. So this is the soil monitoring key. So I now cut this. I click on this, left click, then I now right click, I now cut it. So if I don't want to have to go through the stress of doing this thing, of or if I want to stress myself and not use the board manager, or maybe the board manager doesn't have it, after extracting, I will now cut it. And then I will now come to the place that my Arduino files are being saved under. And we saw in preferences that it was being saved under Arduino inside documents. So I would now paste it. I would now paste it here. I would now paste it here. Another alternative, usually it would be saved under Arduino. All your Arduino files would usually be saved inside your local disk under program files x86, then you would now see like Arduino everything. Then you now see Arduino everything. But then you would usually see it here. But in this case now, you are not saving it here. But there are cases where sometimes like it may override and your Arduino files may save here. But thank God this is the newer version, more or less. So you know that it is saved inside your documents, under documents inside Arduino. So it is here. So because I don't want my Arduino to run into problem, let me just delete this. Because this was just me showing you an example. So I hope you get it. So let's go back to the Arduino, to the explanation that we're going through. So that's it essentially. If you don't want to use board manager to import your board libraries, you can use that. Then edit, undo, redo, cut, paste, select, or go to line, comment on comments. For those of us who don't know what comments is, comments are part of the code that the computer does not recognize. Like let's say now you want to put an instruction inside of it, but then you don't want the computer to go and now be seeing it as error. You can just put slash slash, like the one you're seeing here. Put your setup code here. When we run this, the computer will not see this as an error, even though it's not code. So that's how you comment. Either you do slash slash, or you do asterisk slash, and then asterisk for the place you want it to start, and then slash asterisk. Sorry, slash asterisk for the place you want it to end. Yeah, so it's like that sometimes. Asterisk slash slash asterisk. So if you want it to start there, let it start there. If you want to end there, let it end there. So this entire two lines, because the asterisk slash started from here and the asterisk slash, so these entire lines that these are engulfed in, they are commented out. I hope that makes sense. So what else? What else again? So that's it for commenting. Increase and decrease indent, like the space between each line. You want to increase, you want to decrease. Auto formats, replacing files, increase font, decrease font, find next, find previous, use selection. We know all this from use selection for find. We know all this from Microsoft Word. Then sketch, verify. Verify means okay, check this code and see, are there any errors, are there any bugs, blah blah blah. Verify or compile, then upload it. So after you there are no bugs, there's no error, upload it. Then configure and upload. That one's another. Then upload using programmer. Then export, compile, blah, 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 optimize for debugging. Show sketch folder, include library, manage libraries. You can also import libraries. You can search for libraries online the same way you search for the ESP32 this thing, the ESP32 board manager before. The same way you search for the ESP32 board manager, you can also search that way for libraries and import them. You can also search for libraries that way and import them. And instead of you can also search for libraries and import them like that. So instead of you having to, if maybe the IDE does not have it, you can search for it. Like now, servo library. As I'm saying servo like this, you'll never forget it. Servo library, see it now under GitHub, you see servo library. I select it. As I've selected it to take me to GitHub. It brings me to this page directly. You know what to do. Download the zip file. From the zip file, the only difference now is that from the zip file, after I've downloaded the zip file, after I extract, I've showed you how to extract. After I extract, the only difference now that I will do is that once I finish extracting it, what I'm going to do is that I will now take it to the place that my Arduino files are saved in. And we all know that for my own system, or not your own, it may be different to your own, it may be the same in your own. But for my own system now, it is inside the Arduino, inside documents, inside Arduino. And then inside the Arduino, we now have libraries. So I will now enter these libraries. I will now cut and then paste it inside this libraries folder. So that's the only difference, Sha. I'll cut and paste it inside the libraries folder, not just the Arduino file. Ew, I was apparently I was showing the wrong. Was I showing the wrong? Sorry. This is what I meant to share. So now inside this place now, inside this place, in my own system now, I know that my all my Arduino files are being saved inside documents. So after I've extracted it from downloads, I've pasted it in downloads. I will now cut it. I will now come to the place that I know that in my own Arduino, in my own this thing, my IDE, where my own is, it is saved somewhere. It is saved inside documents. So I will now come to documents. Inside it's now saved. All my sketch, everything about my Arduino is saved inside Arduino. Open Arduino, then come to libraries. So I now double click open libraries. I now paste it inside here. So that's the only difference. That's the only difference. That's the only difference between this thing. That's the only difference between when you're exporting the board manager and when you're exporting this thing. When you're exporting the board manager this thing, and when you're exporting the libraries manually, not from the IDE directly. So I hope that makes sense. Oh, that makes sense. So let's go back. We have spent time. We have spent a lot of time. So I'm almost done, don't worry. Then I was in Sketch. So include library. So or I can just get the library URL, manage libraries. Okay, sorry. Include libraries, manage add zip library. You shall understand there's no library URL apparently. Then tools, auto format, archive the sketch. I want to archive the code. Then manage libraries. You already know what that does. Serial monitor. Serial monitor essentially when you activate it, it just shows you that okay, this is what is going on. This is the values that it is bringing out. I tell the serial monitor what I want to see. Maybe in a digital device, I want to see the on and off state. Maybe in an analog device, I want to see the values ranging from 0 and 1023 that it is giving off. Something like that. I tell the serial monitor what I want to see in my code. Then serial plotter is like a graph of what I'm seeing in my serial monitor. It's just like a graph. Firmware updater. Firmware is like the operating system. Then upload here, blah, blah, blah. Then select the board managers. We have here the different types of Arduino boards. We can see them. I don't know if you can see them, but we can see them different type of Arduino boards under board manager. You can see them. We have Yun, Uno Mini, Nano, Micro, Mega, Mini, all of that. Then if we import more boards like the ESP32, you see this server and ESP32 that I keep mentioning, you'll never forget it. You see ESP32, you see different types of ESP32, you see ESP32 room, you see ESP32 C3, you see ESP32 S2, C3 Pro Mini, all of them. Then reload board data. Maybe you want to flash and reinstall. Then get board information. Then burn the bootloader, meaning you want to flash it. Okay, no, you want to install the OS. That's like the bootloader, the software. Then help is for getting started, environment, troubleshooting, blah 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 blah. All of that, like in the IDE, you can see it. I don't know if you can see what I'm talking about. I really hope you can. And this is exactly why I preferred this thing. Screen recording, but oh well. Then about the Arduino IDE, blah blah blah. Find reference, all of that. I wonder if you can actually see what I'm seeing. But if you can't see it, I'll just do screen record next time. Then this button, shortcut for serial plotter. I told you is graph. Shortcut for serial monitor. So this is the serial monitor. You press it. I've not activated it. I've not connected any Arduino. I've not connected any component, so you can't see it. Then new line. These are like other advanced. If I want there to be a timestamp, if I want to delete everything I'm seeing. So the last and most certainly not the least is now the code, the code environment itself. So in the code environment, we have void setup and void loop. You know how you have a generator. I want to start the generator, right? I want to start the generator, and you've started the generator. You've turned on the fuel pump. You've done everything. You've done everything, right? You've done everything, and you want to like set it up, calibrate it. This is what happens in the void setup. The void setup is mainly for calibration. Like if I want to calibrate, okay, I want to tell you that okay, activate the serial monitor. Okay, these pins, these components are connected to so and so pin, and this pin is an output device, or this device or this electronic component is connected to so and so pin. Blah 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 blah. It's like servo is attached to. Basically, for calibration, you start your generator. That is calibration. I've turned on my fuel pump. I've turned on my generator. Calibration, void setup. It runs only once. You only have to do it once. Void loop now is, as the word implies, loop. So it keeps going again and again and again, over and over and over and over again. So void loop now, what void loop does is it keeps repeating the main code. It runs the main code repeatedly. So based on whatever command, whatever function you want the project to do. Okay, I want the project that okay, at every 1 second it will blink, the LED will blink, or at every 5 seconds the servo will change position from 0 to 90 degrees, from 90 to 0. It will keep going and keep going and keep going until you remove the power source, or until you tell it that issues, until you remove the power source essentially. Or unless you write a command that tells it that okay, only when this happens, that's when this should happen. Otherwise, let nothing happen. But that's for if statements, else statements, if else statements. But I'm go deeper into that. But essentially, void loop is for you part of the code that you want to run repeatedly. Void setup is like, okay, the calibration of the code. Okay, I've started my gen, void setup. Okay, the gen now is continuously supplying light to the house, to the power. After I've done the changeover and everything, it's continuously supplying electricity, supplying electricity, supplying electricity. That is my void loop until I say otherwise. So yeah, so that's it. That's it. This was longer than I anticipated, but yeah, I hope this class brought you value. I trust it brought you value. I trust it brought you value. So that brings us to the end of everything. So that essentially that's all. And that brings us to the end of the class. So in our next class, we'll go further in the curriculum. As I said before, so as I said before, um, we still have a long way to go in our curriculum. We still have much to cover, but we have 5 more classes. Do our very best at least to be able to complete it before the end of the month, or at least before the card classes starts. So yeah, that brings us to the end of today's class. Thank you guys so much for staying to the end. I know it was very long, it was even longer than I anticipated, but we did our best. We did our best. So in the next class, we'll go into introduction to Arduino programming. We discuss for loops, while loops, if statements, else statements, if else statements. And please make sure that you go through all the videos that I've sent in the playlist. Please, because it will make my work, it will make us move faster. We still have like 8 more. We have a long way to go. We still have a long way to go. So please just make sure that before everything, before our next class, make sure that if you did not attend this class, make sure that you go through this recording. I beg. I don't even know why I'm saying this, because if you reach this point, you would have watched it already. You would have pretty much watched everything. But yeah, that's it. And thank you for staying to the end. And I'll see you in the next class, which is on Saturday. Bye. So yeah, let's stop sharing. Bye bye. Thank you so much.